Hi everybody. Here we have a clever workout with proportions. I'm going to work through this one with you, and then I'll give you some that kind of similar that you'll work out and show me that you could. It starts off with a EC being parallel to AB and gives me this data. You ought to make a sketch like that one and throw in the same data as me. It tells me that AD is 3x minus 5. We should label it that way. ED is 2x minus 2. DB, that full length on the right, is 2x plus 6, while CB at the bottom is just x minus 2. Give the lengths of AE and DC, give us these couple of missing lengths in terms of x. I'll pause the video and you can take a look at that, but what I think to myself is, what do I got to add to 2x minus 2 to make it be 3x minus 5? That'd be an x minus 3. And checking on that, if I added those two things up, would you get 3x minus 5? And I'm pretty sure we would. And on the right hand side, what would I add to x minus 2 to make it become 2x plus 6? I think that's got to be x plus 8. You think that through yourself and see if you agree with me. If I added those up, I would get 2x plus 6. So I should write that over here probably. AE plus x minus 3. And what other one were we looking for? DC. Yep, DC was x plus 8. Write a proportion and find the possible values of x. I think I'll try to be somewhat clever. I'm going to say 2x minus 2 is to that full length 3x minus 5. You got to finish that proportion. But I'm thinking, since he did the top part is the full length, you'd have to be the top part is the full length. That would be x plus 8 is to 2x plus 6. And let's work with that. Get those cross products. The product of the means, you do that carefully. I see it'll be 3x squared minus 5x and plus 24x will be plus 19x. Last times last minus 40. Then the product of the extremes would be 4x squared. Outside terms 12x, inside terms a negative 4x. 12x minus 4x, that would be positive 8x. Last times last a negative 12. Let's do what we do with quadratics. Let's drag it all to one side. I'll do nothing on the left hand side. So I subtract 3x squared from both sides. It leaves 1x squared here. Subtract 19x from both sides, and 8 minus 19 would leave me with a negative 11x. Now I bring that negative 40 to the other side and combine it with that negative 12, a positive 40 and a negative 12, that'd be a positive 28. And I'm going to find a way to factor this. You'll shut down this video and factor it yourself, I hope. But I think this is going to work well. Factors of x squared got to be x and x. Look for the factors of 28, I only know a few. I'm thinking it's going to be 7 times 4. I know that this 7 times that 4 gives me a positive 28. So either they're both positive or both negative. Since that middle term is negative, they're going to both be negative. If you check that factorization, I know that we got x squared, but minus 4x and minus 7x give me that negative 11 in the middle. That's important, and last times last is a positive 28. As I set those factors equal to 0, I'm thinking x is equal to 7, or perhaps x is equal to 4. Let's scout around and see if any of those are problematic. I think they might both be valid. I'll make a couple of sketches and check that out. I made a sketch for x equal to 4 and for x equal to 7. And used these lengths that were given. And if x were equal to 4, 2x minus 2, 2 times 4 minus 2, it made this length be 6, and 4 minus 3 makes this 1. Make the other side be 12 and 2, and that's a valid proportion. 6 compares to 1 the way that 12 compares to 2. So I'm thinking that's a valid root. And interestingly, the 7 is also. Had x been equal to 7, this length would have been 2 times 7 minus 2. That'd be 14 minus 2 is 12, and 7 minus 3 is 4. And on the right-hand side, 7 plus 8 is 15, and 7 minus 2 is 5. So that's also a good proportion. I'm not going to use both of those, but I should recognize I could go work the problem from this one or from this one. I'm going to go with x equal to 7 and see what comes. Going back to this page then, I'm going to say with x equal to 7, then what about the length of EC? If x is truly 7, that would be 2 times 7 is 14 minus 5, that would be 9. So I'm going to let this length be 9. Let me sketch it again right quick. Actually, I've got a nice sketch already. When this length would have been 9. And I want to find this length down here. Isn't that what it wants me to find out? Yeah, it wants me to find the length of AB. Let me go ahead and call that guy AB. A couple ways I could go. I'll go from the right-hand side. You could go from the left. 15 compares to 9. The way that full length 20 compares with AB. And 9 times 20 is 180. Equals 15 times x. And divide both sides by 15. And probably by now you know 15 goes into 180 12 times, huh? So I'm thinking that length would have had to have been 12. This one would have been 12. And those are in the ratio of 9 to 12 and 3 to 4, just like this length of 12 to 16 was in the ratio of 3 to 4. So I'm happy with that. Find the length of AB, and AB would have been 12. Here's a question I haven't shown you before, and it's really a kind of a clever one. I might have shown you, but in class once. Consider triangle ABC. If you were to show the bisector of angle A, I wouldn't do that. Show the bisector of angle A. And I'll try to make it look pretty close to a true bisector there. And what would these sides have to be? What two lengths would side CB be cut into? And a lot of people who don't know much about geometry say, well, there are going to be 2 equal halves right there, 7½ apiece. But this is not true. In fact, allow me to call this part X right there. And this other part, don't want to call it another variable. And if this full length is 15 and this top part is X, that bottom part would have to be 15 minus X. And the theorem goes like this. The bisector of an angle divides the opposite sides into lengths that are in proportion to the adjacent sides. So a proportion that I could work with here would be 12 is to X as 18 is to 15 minus X. You could switch the means on that proportion. You could say 12 is to 18 is X is to 15 minus X, but you're going to get the same cross products. Let's go ahead and cross multiply, see what comes. I get 18X, the product of the means, equals, and going this way, 12 times 15 is 180 minus 12X. I solve this little equation. I would have to add 12x to both sides to get rid of that negative 12x on the right. And when I do, I would have 30x on the left is equal to 180. Divide both sides by 30. I'm thinking, well, x would have had to have been 6. Now, let me think about that for a second. This length could have been 6, and this would have been 15 minus 6, which would have been 9. And that's a pretty good looking proportion. 9 is to 6 as 18 is to 9. Wait, hold on a second. What do we get for this length over there? If that were 6, yep, that would have been 9. And 12 is to, excuse me, I got something screwy here. Let me do that better. 12 is to 6. This side is to its part as 18 is to 9. I apologize. I think of that. That confirms it. Yep, that length could have been 6. I'm going to sketch this thing again and work this second question. So with a quick sketch, this time it says, show the bisector of angle C. So I made that same sketch, and I'm going to show the bisector of angle C. And act like that was the bisector right there is going to divide this side, which I know had a full length of 18, into two parts. Doesn't matter which side I call x. I'll call this one x. But then what should this length have to be over here? It's got to be the 18 without that x, so that's got to be 18 minus x. We're going to write a proportion. 12 is to 18 minus x, as 15 is to its part, just x itself. Let's see what comes from this. Cross, multiply, and go. Then we got 12x equals, and 15 times 18. Alexa, what's 15 times 18? 270? I think so. Minus 15x. Alexa, what's 15 times 18?
15 times 18 is 270.
Good, that's what we thought it was. I'm going to bring that negative 15 to the other side, and I got 27x is equal to 270. Divide both sides by 27, and it turns out in this case x would have been 10. So this length would have been 10, and this length would have had to have been 18 minus 10, therefore 8. And I'm liking that too. I'm thinking these are nicely proportionate. 12 is to its part 8, as 15 is to its part 10. Cross multiply and see what you got, 120 either way. So, yep, that would work that way. The bisector of angle C would have given it two parts of length 8 and 10, which are in proportion of 12 to 15. So we worked that question out. Here comes a pretty great question too. It says, you inherited some land. We'll act like this is the piece of land that you inherited. And you're going to use proportion to find all these lengths. These are parallel. You can tell that's true by the arrowheads. And I'm going to figure out what these individual parts are first. And the way I'm going to have to do that is to figure out what's this full length across the bottom. And I see that there's 30, for that 14 and 60 going to be 30, and 10 more is going to be 40. And the way that we can get these upper lengths right here, let me just set up a proportion for HG is part is to whole as part is to whole. What would that mean? Part HG is to the whole length 60 as part 16, the one that corresponds with the HG, is to that full length 40. We're going to cross multiply and see what comes here. And 16 times 60, I think is 960, is equal to 40 HG. Divide both sides by 40. I can knock a zero off of those. You can use a calculator, but 4 goes into 96 24 times. So I'm thinking HG would have been 24. This part would have been 24. Let's go further. Let's get GF. And I'm still thinking this part is to that full length as this part is to that full length. 10 is to 40 as GF is to 60. Cross multiply, see what comes, and we get 600 going that way is equal to 40 times GF. Divide both sides by 40, and we'll figure out about GF. I can knock a zero off of each one of those, and 4 goes into 60 15 times. So I'm thinking GF should have been 15. And you might be thinking, well, I'll add those two up, subtract from 60, I'll know this length over here. And I said, yeah, I guess you could. But I'm going to find it using the same thought and then see if they don't add up to 60 as they should. So part is to whole, FE, is to the full length 60 as that part CD, which was 14, is to that full length 40. So we're going to have to cross multiply here. I got 40 FE and 14 times 60. Let me see about that. Would be 600 and 240. So 840? Yeah, I think so. Alexa, what's 60 times 14?
60 times 14 is 840.
Good. I'm going to divide both sides by 40. Now to find the length of FE. I can knock a 0 off of each one of those, and 4 goes into 80 20 times, so it goes to 84 21 times. And I think an FE would have been 21. Now, after the fact, we ought to add these up and see that they add up as they should. And 21 and 24, it makes 45, and 15 more makes 60. So, yeah, these things add up as they should, and they're nice in proportion with the other side. This is a really good question. I'm going to pause that video for a second while you think about a way to solve it. I think I'm going to sketch this on another piece of paper. The last question on this page that I was going over with you here tells me that if AH is 10, and let that length be 10, and ED is 30, find these two lengths in here. They were GB and FC, but I'm going to find this length right here. I'm going to call it X. That's really going to be length GB. And it's really kind of interesting what you must do. These are a series of trapezoids, but they are not similar. These are parallel lines. I understand that. But those are not similar trapezoids. I'm going to have to drive up some similar things here. And I can do that by extending this side, put a ruler on it, mister, and bringing this across here. So that's one continuous segment right there. Sure to use a ruler. And let me call this distance X. I got to find that length X. Let me call that X. Let me call it A for a minute, because I already got X over here, don't I? And I do see that I do have similar triangles here. This triangle is similar to this big triangle. And I can compare the size. A compares to 10 the way that this full length, A plus 40, compares with this length 30. This will give me the value for A. I can cross multiply here. That would give me 30A is equal to 10A plus, and 10 times 40 is 400. Going to subtract 10A from both sides, and I got 20A is equal to 400. Divide both sides by 20, and A would equal to 20. This length would have been 20. A good exercise would be for you to find this length and redo everything I'm about to do right here. That would be excellent. We should probably do that if we were in class together. But I got A is equal to 20. Now I'm going to get for X, and I'm going to call this guy Y. Those are the things I'm supposed to come up with the length of here. Here goes. I can do that. 10 is to 20. Comparing this length with that one, as this length X is to this full length. That full length is 36. When we cross multiply there, I get 360 is equal to 20x. Divide both sides by 20. We can get x out of that. It's going to be 18, isn't it? So I say this length would have been 18, which is reasonable. It's got to be bigger than 10, less than 30, so I'm thinking that 18 is okay. Now I'm going to go for y with the same ticket. 10 is to 20 as y is to the full length across the bottom to this point. That would be 20 and 26. That's 46. Cross multiply here, we'll have 460 equals 20y. Divide both sides by 20. Let's find the value of y. And knock a 0 off of each one's pretty easy to do. And 46 divided by 2 would be 23. Yep, that length would have been 23. Let me scribble that right there. A clever thing for you to do, call this length over here z and work it out. 10 is to z as 30 is to 60 plus z. That will give you z, and then rework these two lengths. See if you don't get them to be 18 and 23. I'll work it from both sides, and I'm only going to get the same answer. Okay, so here's a couple things for you to work on, and I'm going to bring you an assignment right next.